This is a standard, what was known as a open differential. Open, I'm not exactly sure why that term came about, but let's just call it non-limited slip. Okay, this thing can freely do its job of differentiating speed from one axle to the other. Okay, and what I mean freely, it's that there's no limited slip here to try to tie these two together. We look at this and we all spin this and we go, well, how does this thing work? You have to remember that this thing is turning here too, okay? And while this thing is turning, if that inside tire spins up, we're adding RPM on that inside tire. Let's say this is the inside tire and the car is going to be traveling around the turn. This tire would spin up, adding RPM relative to the speed that the differential is turning. This guy would actually be rotating forward. Notice the other gear is going slower, it's backing up. We see it as backing up, but remember, if we put this thing into motion, we're going to have the inside tire spinning up while the other tire is slowing down. And what's the difference? Exactly that. I guess that's where the name the differential comes from, is because whatever is being added to this side here in regards to wheel spin is being subtracted from this other tire, okay? This is a factory helical limited slip from a Mitsubishi Evo, and how these differentials work, this is a planetary helical limited slip, okay? And you've got sun gears here that have a very high pressure angle on them, and it's important because you don't want this gear to break, so you want a high pressure angle. That's the angle that these gear teeth are at. Okay, this creates a high pressure angle gear creates a lot of radial thrust load. That radial thrust load is your friend. That radial thrust load, and these gears are also high pressure angle gears, that radial thrust load causes these gears to force away from one another. When they force away from one another, these gears push on this outer housing, okay? And you can see this outer housing, in this case, you can see how the sun gears are, or I'm sorry, the planetary gears. This is the sun gear, this is the planet. That high pressure angle forces these gears outward. So the way that the helical works is that it is this housing here that is power is being fed from the center differential into this through a hollow spline shaft known as a torque tube. Okay, power is being transmitted into this outer housing. This outer housing is forcing the sun gears in the center to turn because of the way that the gears are being the planets are being forced to follow inside of their respective bores. I'm going to be the housing turning this, and this gear is going to be stationary, and you can see these gears want to force themselves out, okay, how they're going outward from the center. They're forcing themselves outward at the housing, okay? That's where the friction is being generated, is between the thrust surface, or this is ultimately a thrust surface, or the tip of the gear teeth up against that outer housing. You can almost think of it as kind of like when you hit the brakes on a car, you're rubbing that brake pad against the rotor very hard. The thrust force is these planets being pushed outward against the housing, opposing the ring gear. These guys are going to want to force outward, and they are going to push at the housing, and that's where the friction is being generated, okay? You're going to be limited, again, with friction in the high-power cars, even with a bunch of aero on the car, a high-power Evo coming out of a turn, that front inside tire is so light, you would see that front inside tire drastically take off with speed compared to the rest of them. That is power that is being bled off to a spinning tire that's not accelerating the car, and that's making your lap time slower. With that one wheel getting away, that clearly should be an indication that you're not getting enough power to that outside front tire, because all that power is being pissed away on that inside front tire, okay? So the car is not going to claw out of the turn. It's not going to use that outside tire to help turn the nose of that car so it doesn't go off to the grass. But you still are going to be at the limitation of the real estate space you have, okay? And what I'm referring to is inside of the carrier. You only have so much space to put put a planetary helical limited slip, you can only make the gears so big. Everything still has to fit inside of this housing. You want to generate more friction, you'd make the planetary gears larger diameter so they have greater surface feet per minute, more friction. However, the housing gets thin. You're going to break the housing. You could try to go the other direction and make the planet smaller, but then this is where all the force is localized, is it's going to be heading out the axle shafts to the front wheels. So this gear still needs to be robust, or you're going to end up breaking this. Another differential, and this is my favorite type of design, this design would be a floating cross shaft type design, much like the rear differential and the Evo. These have been around for a long time. We're also known as a Salisbury limited slip. Why Salisbury? I don't know. Why a Salisbury steak? If you watch the RX-7 video, this is a similar type of differential design, okay? This right here is actually a torque tube that is produced on the other side of the state by Liberty's Gears. It is incredibly durable. But the power is coming out of that center differential. It's going to go through this torque tube. It's going to go to this front differential. This front differential has got a side sheave, okay? This side sheave keys in to this guy, so now this is all turning, okay? Power's then going to go on this cross shaft, okay? And this cross shaft, we'll take the gears out of here just to get rid of some of the distraction. Power's going to be, imagine this cross shaft or this diff housing turning, the side sheave turning inside of this guy, okay? This diff has a 4-post cross shaft. This guy here rides inside of this ramped groove right here, okay? And the ramp angle.
Can you kind of turn it sideways so
Yep.
you see the ramp?
The ramp angle, let me get the, here, get this out of here. So the power is going to be transmitting through that torque tube, through that main body, the outer housing, into the side sheaves. From there, power is going to be transmitted through the cross shaft. This is a 4-post cross shaft. This thing here has a difference in ramp angles on this thing. This is a one-way where the back of this guy is completely flat, okay? This is up against this flat. This would be a one-way, okay? This thing is only going to be able to ramp in this direction right here. And you can see the way that this guy rides up this ramp. This piece actually is ramping and pushing back, squeezing on the friction discs, okay? The friction discs, they just happen to be keyed to the housing, and they also are keyed to the side gear. The side gear in this thing has keyed marks so that these guys can key themselves to it. So you've got an inner and an outer, okay? Obviously the outer, we refer to that as an outer because it's got the keys or the tangs on the outer, which key themselves to the outer housing, going with the side sheave. And then the inners are keyed to the gear. And this is how this thing is able to generate its friction, is that these discs, these outer discs, are held stationary with the housing. They're going to rotate at whatever speed the housing is rotating. The inner tang ones are going to be rotating with the gear. If no limited slip action is happening, then these guys here are just riding along all together at the same speed. There's no problem. But let's say that thing we get a tire loose on that car. Either one tire has more traction than the other, or in the case of the Evo, we want to be able to apply more power, more torque ultimately to that outside tire that is carrying all the weight, because we want to use it to help torque vector the front end of that car, make that thing go in that direction. We're not going to have that inside tire spinning up with this type of differential. By its design, it can apply more friction, more squish on these friction discs in relation to how much torque is being transmitted through this cross shaft. The more that you kick this thing's ass, the more that you force this thing to take the power, the more that this guy forces the ramps to to squish up against the friction discs and lock up the differential. This differential has a tremendous amount of surface area as opposed to planetary helical type differential. If you total up all the surface of what the side gears are making contact in this differential, there's substantial more friction surface area on these friction discs, okay? What this is going to allow you to do is going to be able to put a much more clamp force on here, generate higher friction coefficients with less wear. This is definitely a better way to go. Why did the car not come with this differential? Cost. There's a lot of manufacturing that goes on into this thing as opposed to making planetary helical. You could buy splined rod, okay, something that already has a gear continuously cut. So you imagine this thing being one piece and bar length, and you can just, you know, part this off on a CNC lathe, chamfer your edges on this thing, you know, drill your center hole, chamfer the edge, mill this out in the center right here, grab onto it with your sub-spindle chuck, part this off, repeat. This housing is relatively easy to manufacture. This side here is relatively easy to manufacture as opposed to this part here. Manufacturer wants to be able to haul ass and make a profit. This differential here, this planetary helical, is easy, cheap, durable, multiple tooth of engagement. That's probably the biggest benefit for drag racers. Drag racer guys, you should probably stay on this differential just because you've got multiple teeth of engagement. What I'm referring to is you have an awful lot of teeth engaged and these things are dynamically balanced load-wise. This is definitely a durable differential. The outer housing, as you can see, it can be trouble. We can fix this problem for you guys if yours is not too far cracked. What we do is we would machine these windows out right here, put a generous corner radius in this, and then shot peen this outer housing. We found that by simply doing that, we can keep this outer housing from failing. Or go to a wave track differential. There's a thrust washer in between these guys, okay? Some of the cool kids have figured out ways to put carbon fiber thrust surfaces inside of here to generate more friction, which is a good idea. That would be a wave track differential. They've done a very good job on that differential. I do like the Cusco friction disc. I do like this differential overall. It's well engineered. They do cost more, but you really get what you pay for. If you're honestly looking at a way to reduce lap times and have a lot more freedom of where your car placement is on corner exit, you definitely want this style differential, a floating cross shaft, torque reactionary differential. Wave Track makes them, OS Geiken makes them, I think even M Factory makes them. We should really have a Wave Track differential out here. Rooter!
We don't got time. We're like,
Oh, we're going to lunch, boys. We're all going to lunch. All right. Hungry.